Hello everyone. Now we have to discuss the analysis of delta connection. Last class what we have discussed the analysis of star connection, right? In that what we have derived the relation between line and phase quantities. In that the phase current should be equals to line current, but coming to voltages, the line voltage which is equals to root 3 times of phase voltages, right? Now we can discuss the analysis of delta connection. In that how the currents and voltages are related with respect to line as well as phase quantities. Okay, first we have to discuss windings connected in delta, same like in case of star connection, how the three phase windings are connected in delta in the alternator, right? Because the source of energy is nothing but three phase alternator. This is another winding, this is another winding, right? Let us say this is R phase, this is Y, this is B. Means this is three phase three wire system, right? There is no neutral point in delta connection. This is one wire, this is another wire. So from B we have another wire. Finally we have R, Y, B. Okay, let us say the current through this phase, the phase is what? Between R, Y one phase, between Y and B another phase, between B and R another phase. The current through this phase is nothing but IRY. Like that through this phase IYB, like this is IBR. Okay, so at this node the current is entering, IBR is entering, IRY is leaving. Okay, therefore currents completed. Then what about line currents? The current through this wire, through R wire is nothing but IR, through this IY, through this IB. Means see, at this point R, IR is entering, IBR is entering, IRY is leaving, right? So IR plus IBR which is equals to IRY. So like that, by using KCL at different points we have to write the KCL equations. From that we can get the relation between phase currents as well as line currents. Okay, now what about voltages? What about voltages? The voltage which is present in this phase RY is nothing but VRY, right? Like that the voltage which is present between this is nothing but VYB. Based upon phase sequence, here I am providing the phase voltage RY, YB, then BR. Okay, this is VBR. Clear? Then by inspection, what is the line voltage which is present between this, right? Which is present between two lines VRY, VYB. Finally between R and B we have what? PBR. So by inspection we can say that the voltage which is present in this phase is nothing but VRY. Like that the voltage which is present between two lines is nothing but VRY. So by inspection we can say that the line voltage should be equals to phase voltage in case of delta connection. Like that the line current should not be equals to phase current. Now we have to get the relation between the currents in this delta connection. But in case of star connection we have derived the relation between voltages, because in case of star connection voltages are not equal, only currents are equal. But in this case of delta connection voltages are equal but currents are not equal, right? Before that, so this is the connection diagram, three phase connection diagram of delta. We can draw this delta connection in another manner. Delta connection of phase windings, right? So we can draw this delta connection in another manner. Let us say this is the terminal A dash. This is one side of this winding, R winding, A dash. Like that, if we consider B conductor, that is B Y phase, B dash. Like that, this is C dash, right? So if you consider any winding, R winding, Y winding or B winding, let us notate some points A dash, B dash, C dash. Okay, for that, right? This is R phase, this is Y phase, this is B phase. Clear? Then you know that this is A dash, B dash, C dash. Now let's connect those points. Here at this point A and C dash are connected. At this point A dash and B dash and C. So A dash and B are connected. Like that, B dash and C are connected. Like that, C dash and A are connected, right? So this is the another diagram of delta connection. So we can draw like this or we can draw like this. The current through this phases is nothing but what? Between R and Y we have what? I R Y. Between Y and B we have Y B. Between B and R we have I B R. That's it. Clear? So this is the phase windings which are connected in delta manner. That is, the source is nothing but was three-phase alternator. So in that three-phase alternator, the three windings are connected in delta manner also, whether it is star or delta. So this is one type of connection. So we can draw this delta connection in another manner. This is another manner. Now we can discuss the vector representation. Okay, that is heading is what? Vector representation. How we can represent the three vectors? So let us consider phase currents. Okay, you can consider any. Here I am considering phase currents. So nothing but phase currents, right? IYB, which is nothing but what? Phase current at an angle minus 120 degrees. Like that, at an angle minus 240. Okay, so for that we can draw this phasors. Let us say this is R. Okay, then this is, sorry, this is Y. This is B. See, the phase sequence is what? At any case, we have to follow the phase sequence. That is what? Anti-clockwise phase sequence, right? Anti-clockwise phase sequence, right? So the first crossing vector over observer is what? R, later Y, later B. Okay, the angle between these two is what? This is 60 degrees, 60 degrees, 60 degrees. But in this delta connection, it is very difficult to, not difficult, very confusing, right? See, this is 60 degrees. Obviously the angle between these two is what? 120 degrees, like that. Between these two is nothing but what? 120 degrees, like that. Between these two is nothing but 120 degrees. See, 120 between R and Y, 120 between B and R, 120 between Y and R is Y and B is 120. R and Y is 120. So it is very confusing to draw the phasor diagram in delta manner. So for better understanding, we can draw any phasor with respect to three-phase circuits is what? Star notation, right? Therefore, we can draw, first we can draw, let us say this is IRY, phase current. After 120 degrees of this, we can get IYB. After 120 degrees of this, we can get IBR. That's it. This is very easy to represent. See, between these two, 120, 120, 120, right? So like this, we have to draw any phasor in case of three-phase circuits. Okay. What we have discussed? The connections in delta winding, delta connection, and the delta connection of phase windings, later the vector representation of delta connected system. Okay. Next we have to get the relation between line and phase quantities in voltage and current. This is very important. Okay. Before that, first we have to draw the connection diagram. Right. This is one wire. This is another wire from this B. This is another wire, right? This is R, Y, B. This is the line current IR. This is the current IY. This is the current IB. Clear? Then what about that? This is what? Line voltage VRY. This is the line voltage VYB. Like that, the line voltage between these two is nothing but VBR. Completed. Okay. Then what about phase voltages? This is R, Y, B, between YB, between these two VRY, between these two VBR. Then what about currents? The current through this phase is nothing but IRY. The current through this phase is nothing but IYB. The current through this phase is nothing but IBR. That's it. So we have represented line currents, phase currents, as well as line voltages, phase voltages. Okay. Next, is there any? Yeah, all are represented. Then now we can write important observations here. Okay. There is no neutral point available in delta connection, right? There is no neutral point available in delta connection. So by inspection we can say that what? The voltage which is present between these 2 points is nothing but phase voltage. The voltage which is present between these two lines is nothing but line voltage. See, whatever the voltage which is present between these two lines is nothing but VRY, which is also present or which is also across these two node points, right? VRY. So the phase voltage which is equals to the line voltage, like that VYB, which is equals to VYB. Whatever the voltage which is present across these 2 points is equals to the voltage which is present between these two lines. This is very, very important observation. So by inspection we say that what is that? Whatever the voltage which is present between two lines or is same as the voltage present between two node points. Okay, that is in delta connection line voltage which is equals to phase voltages. That's it. In case of star connection, line currents is equals to phase currents, but here voltage, no? So in case of delta connection, line voltage which is equals to phase voltage. That's it. Next we have to discuss currents. That is, for that we know that IR, IY and IB, which are nothing but line currents, right? Like that IRY, IYB and IBR, which are nothing but what? Phase currents. And we know that this phase current which is not equals to line current in this case, because both are different. So now we can get the relation between those two, same like in the case of star connection. In the star connection, what we have done, that is we have to get the relation between voltages VL and V phase. So the same like here also we can do the same analysis, because why these are not equal? Because it may be observed that current in each line is the vector difference of two phase currents. Vector difference of two phase currents. That is, see, from this line current is nothing but what? At this point IR is entering current, IBR is also entering, IRY is leaving. Means what? IR plus IBR which is equals to IRY. Means what? To get line current we have to subtract this IBR current from this IRY, right? See, at this node points R, Y, B, by using KCL we have to write the current equations. Okay, that is IR is entering, yes, IBR is entering, which is equals to IRY is leaving. Like that, at Y Iy is entering, and see at this point, see from this Iy is entering. So at this point Iy is entering, IRY is entering, Iyb leaving, right? Iy plus IRY, which is equals to what? Iyb. Like that, Ib plus Iyb, which is equals to what? Ibr. Okay, this is the observation from the different nodes. IKCL at R, Y and B points. Okay, so from this, line currents, what are the line currents? IR, right? IY, IB, those are the line currents, which is nothing but what? IRY minus IBR. From this, IYB minus IRY. From this, IBR minus IYB. See, this is the definition for this. See, it may be observed that current in each line is the vector difference of two phase currents. See, this is one of the phase currents, vector difference of two phase currents. Clear? So nothing but vectors only. Okay, now we have to get the relation between the currents. IR equals to IRY minus IBR, IY is equals to IYB minus IRY, like that IB is equals to IBR minus IYB. Okay, let us write the points here. IR, which is equals to what? IRY minus IBR, IY, which is equals to what? IYB minus IRY, like that IB, which is equals to what? IBR minus IYB. So based on this, we can draw voltage, right? So to get that, first we have to draw the phasor diagram. Okay, let us draw. So in case of delta connection, the line voltage should be equal to phase voltage, right? So we are doing the analysis with respect to currents only. Why? Because we are going to get the relation between the currents only. That's why here I am considering phase currents. Let us say not this much. This is what? Let us say this is IRY. Okay, after 120 degrees of this IRY, we all know that. Before that we can write IRY at an angle 0, or I phase current, or you can write I phase at an angle 0. Okay, IYB, I phase at an angle minus 120, IBR, which is equals to I phase at an angle minus 240. Clear? So based on this we have to write. Next, this is what? IYB, like that. This is what? IBR. This is IRY. Clear? See, to get line current IR, IRY minus IBR. So we have positive IRY, but we don't have negative. So for that, let us take negative. This is negative IRY minus IRY, like that. This is what? Minus IBR, like that. This is minus IYB. Clear? we have all. So therefore, to get this IR by minus IBR, so we have IR by IBR is what? Minus IBR, like this. So from this, so like this we have to get. So at this point we can have the resultant of this IRY and minus IBR, right? So from this is what? IR, line current, right? See, what is the phase angle between this IRY and this is what? Phase. This is line. This is what? From here to here 60 degrees. Obviously this is what? 30 degrees. See, phase current leads line current by 30 degrees. Phase current leads line current by 30 degrees. In case of star connection, line voltage leads phase voltage by 30 degrees. Here phase voltage leads by line voltage by how many angles? 30 degrees. That is, line current lags phase current by 30 degrees. Or you can say that is, we can write, see, IRY, which are nothing but phase voltages. Now IR, which is equals to I line, at an angle is what? Plus 30 or 0 or minus 30. See, what is the condition? Line current lags phase voltage by 30 degrees. Sorry, phase current. Phase current, that is phase current. So based upon this condition, we can write, that is IR, which is equal to IL at an angle minus 30, right? This is IY, IL at an angle minus 150, IB, IL at an angle minus 270. That's it. IR phase currents are like at an angle 0, like that line currents lags phase currents by 30 degrees. That's it. Like this we have to get. This is the angle. So like this we can draw I by IB. Okay. Now we have to get the relation between line current and phase current. So by using this we can get the value of IR. That is IR, to get IR, which is equals to what? We can apply, that is positive IR by negative IBR, that is IR by whole square plus minus IBR whole square plus 2 into mod IR by minus IBR cos 60, right? Always the angle between these two is cos 60. So by using parallelogram law we can get that relation. So from we know that IRY and IBR are nothing but what? Phase currents. Therefore IR, which is equals to what? Which is equals to plus this is also I phase square, because 2 into 1 by 2 gets cancelled. This 2 and this cos 60 gets cancelled. From this IR, which is equals to what? 3 I phase square, which is equals to IR root 3 I phase, which is nothing but IR is what? line current, right, root 3 I phase. This is the relation from this delta connection. Similarly, you can do the analysis for IY, that is root 3 I phase, like that IB, which is equals to root 3 I phase. Okay. So, a conclusion. What is that conclusion? In delta connection, VL which is equals to V phase, IL which is equals to root 3 I phase. In case of star connection, IL is equals to I phase, VL equals to root 3 V phase. There line voltage leads phase voltage by 30 degrees. Here line current lags phase current by 30 degrees. This is the observation from this delta analysis.